Hi, welcome to this lesson on trigonometry compound angles. Let's have a look at question 7. With the use of a diagram, find the following trigonometric ratios if it is given that 13 sine alpha plus 5 equals 0, where alpha is in that given domain, and 13 cos theta minus 12 equals 0, where theta is in this given domain. So let's go ahead and sketch those and then work out these questions. So first thing I'm going to note here, that is I can rewrite this as sine alpha. So I'll bring over the 5, which is negative 5, and then divide by 13. So negative 5 over 13. And then here I'm going to get cos theta. If I bring over negative 12, it's positive 12 divided by 13. So notice sine alpha is a negative number here. So if you look at your cast ratio, cast diagram, where's sine negative? It's in the third and fourth quadrants. And because of this given restriction from 0 to 270, which is the first three quadrants, where they both match up is the third quadrant. So that's where this line will be for this angle. Similarly here in this cast diagram, you want cos to be positive. So that's either in the first or fourth quadrants. But because of this restriction between 90 and 360, it's either the second, third, or fourth quadrant. So where they both match up is the fourth quadrant. Okay, so let's go ahead and do the first one. Sine alpha equals negative 5 over 13. Okay, we deduced it's going to be here in the third quadrant. Okay, so how do we work out these values? So here's the angle alpha. It's that entire angle. Okay, so it's an obtuse angle, right? Bigger than 180, less than 270. Now, it says negative 5 over 13. So remember, sine is opposite over hypotenuse. Now, your hypotenuse is always a positive length. Always, by definition, the length of a line is a positive quantity. So the negative 5 that we are looking at here, the opposite side has to be this thing here. So the magnitude, which I denote here by the absolute value of negative 5, or the absolute value of 5, is just 5 units. But the y-coordinate here, so if I call this point P, the y-coordinate is negative 5, because it's on the negative y-axis. Okay, so we just need this x-coordinate value, and then we know everything about this line. Well, I can use the Pythagorean theorem here on this right angle triangle. Okay, so I have 5, 13, and I need this number, let's call it x. So by Pythag, I have x squared plus 5 squared equals 13 squared. So x squared plus 25 equals 169. Then if I subtract 25 on both sides, I get 144. So x could be plus or minus 12 if I take the square root. But look where we are, in the negative x axis. So the value here must be negative 12 on the x-axis side. So it's really important from an analytical geometric perspective that we get the coordinates correct. Okay, and then for the cos one, so we have here cos of theta. So let me just put it up here. So cos of theta we worked out as positive 12 over 13, right? And we said it must be in the fourth quadrant, so somewhere up here, right? Okay, so now let's try to draw it a bit more accurately, because so it's adjacent. Yes, okay, so it's going to be something like that, right? So this is the angle theta, okay, reflex angle, I believe, so bigger than 270, less than 360. And you want cos of theta, that is your adjacent side over your hypotenuse. So again, hypotenuse length is always a positive quantity, 13. So the adjacent side here, so this angle is going to be this x-axis side here, 12. Okay, so we just need from this right angle triangle to work out this thing here. But by Pythagoras, we actually worked this out already. This length here is also going to be 5 units in magnitude, but negative 5 on the x-axis. So this coordinate, if I call it q, is given by positive 12 and negative 5. Okay, so now we have all the information about these diagrams, and we can just go ahead and work out the solutions now. Okay, so let's go back here. So now we want tan alpha minus tan theta. So what is tan alpha? That's going to be your, so let's go back to the diagram here. So tan of alpha is going to be opposite, okay, over adjacent. So the opposite side is negative 12, negative 5, and the adjacent side is negative 12. Okay, so opposites over adjacent, so negative 5 over negative 12. Okay, minus tan of theta. So again, theta is going to be opposite, so negative 5 over adjacent, positive 12. So minus negative 5 over positive 12. So we've got to make sure we do our algebra very carefully here. Negative 5 over negative 12 is positive 5 over 12. And then minus minus becomes plus 5 over 12. So we have two amounts of 5 over 12, so they are 10 over 12. And we can simplify that. 2 goes into 10 5 times, 2 goes into 12 6 times. So that's 5/6. Okay, now what about sine of theta minus alpha? Well, I can use compound angle formulae here. So it becomes sine theta cos alpha minus cos theta sine alpha. Right, sine cos sine, theta alphas and minus. Now sine theta, okay, so if we go back here, sine of theta is opposite of hypotenuse, so negative 5 over 13. Then cos alpha, if I go back here, cos alpha is adjacent of hypotenuse, so that's negative 12 over 13. Okay, minus cos theta, that was 12 over 13, we given that, and then sine alpha was negative 5 over 13. So if I simplify that, negative times negative is positive. So 5 times 12, that's going to give you 60, and 13 times 13 is 169. Then this negative and negative here becomes positive, and again, 12 times 5 is 60 over 169. So this simplifies to 120 over 169. Okay, and then lastly, cos of alpha plus theta. That's going to give you cos alpha cos theta. And because it's plus here, it's minus in the middle. Sine alpha sine theta. Okay, cos alpha, we worked out that's negative 12 over 13. Cos theta was 12 over 13. Minus sine alpha was negative 5 over 13. And sine theta is negative 5 over 13. So negative times that positive number gives you negative 144 over 169. Then this negative times a negative is positive. Distributed with that negative becomes negative. So negative, and then you have 5 times 5 is 25, and 13 times 13. So if I add these two negative numbers together, I get negative 169 over 169. That gives me negative 1. Okay, so in summary, when you do these types of questions, we need to first of all make sure we use our cast diagram correctly to get the correct quadrants of where we place the angles, and then interpret the angles using analytical geometry very carefully in terms of the x and y coordinates. Also noting your hypotenuse value is always a positive value. That is how it's defined. It's the length of a line. Okay, and then from there, any other questions we do using the trig, we can either directly look on the graph, or if it comes to compound angle formulae, we simplify it by expanding using the formulae and then plugging in the values using the graph. All right, this is how we do this type of question. I'll see you in the next one.